Welcome back to the deep dive. So I have to say, looking at the tech headlines this week, the mood is, well, it's complicated.
Complicated is one word for it.
I spent a good chunk of my morning just doom scrolling through Reddit and a bunch of tech forums after the big Nvidia keynote at CES 2026, and the anger is, it's palpable.
You're talking about the elephant in the room. Or I guess the elephant that was hidden in the room.
Exactly. I mean, Jensen Huang is on stage for 2 hours. 2 hours.
A long time.
And everyone is just waiting for one thing.
Uh-huh.
The GeForce RTX 6090.
Mm-hmm.
The gamers, the enthusiasts, the people who actually built this company's reputation in the first place.
It's got nothing.
Nothing. The internet's calling it the No Graphics Card Spring Festival.
Yeah.
It really feels like a snub.
And I get it. It definitely stings for the consumer market. It's a valid frustration because those are the people who've been buying the cards for 20 years.
Right.
But if we look at the source material we have today, that disappointment might be missing the real story.
How so?
Focusing on the lack of a gaming card is kind of like complaining about the lack of cup holders on a rocket ship.
Okay, that's a bold comparison. Are you saying the gaming market is just, what, a side hustle for them now?
I'm saying the message Nvidia sent wasn't about a new consumer product at all. The message was game over.
Game over.
They aren't just playing the hardware game anymore. They are looking to checkmate the entire industry of artificial intelligence.
That sounds pretty ominous.
Yeah.
So the thesis here is that we're watching a fundamental identity shift.
Precisely. For years, we've known them as the company that sells GPUs, components. You buy a chip, you plug it in.
Mm-hmm.
But the sources are clear. Nvidia has transitioned. They've gone from a company that sells components to a company that sells entire AI factories.
AI factories. That's a term they kept using. It sounds a little bit like marketing fluff, though. Doesn't it just mean a lot of computers in a room?
You'd think so, but no, it's a really specific architectural change. So today we need to break down exactly what that means. We're going to look at this new Vera Rubin architecture, this massive unit called the NVL72.
Right.
We need to talk about why they had to reinvent the CPU, how they're changing the way AI remembers things, and finally, how they're dragging AI out of the chatbot window and into the physical world.
All right, before we get to the shiny new stuff, I think we need to establish a baseline. To understand why they built a factory, we have to look at what people were dealing with before.
A bad old days.
The source material calls the state of AI just 5 years ago, around 2021, a DIY nightmare.
That's putting it lightly. It really was miserable.
So paint that picture for me. If I was a tech CEO in 2021 trying to train a model, what was I up against?
Well, you're basically a general contractor trying to build a skyscraper without a full set of blueprints.
Okay.
You'd go to Nvidia to buy your GPUs. Then you'd have to go to Intel or AMD for your CPUs. Then you go to a networking company, maybe Mellanox for all your cables and switches.
So you're buying all these parts from different vendors.
3 or 4 different vendors, all with different protocols, all speaking slightly different languages.
It's the classic Frankenstein problem. You're trying to stitch together parts that weren't really designed to talk to each other.
Exactly. And you'd hire a system architect, pay them a fortune, and spend months just trying to get these things to handshake correctly. And the real kicker, the efficiency.
I saw that stat in the notes. It said efficiency was often only 60%.
Right. And think about that for a second. You spend hundreds of millions on hardware, and nearly half of its potential power just evaporates because of compatibility headaches.
So you're paying for a Ferrari and driving it in first gear.
Because the transmission doesn't quite fit the engine. Exactly.
So Nvidia looks at this 60% number and realizes we can't just sell the engine anymore.
They realized they had to sell the whole car. Or, in this case, the factory. Enter the Vera Rubin NVL72.
Let's talk about this thing. Visually, it just looks like a standard server rack, a big metal cabinet. But the sources keep calling it a super chip. How can a whole cabinet be a single chip?
That's the paradigm shift. Physically, yes, it's a rack with 72 GPUs and a ton of other silicon. But logically, to the software, it functions as one single massive unit.
So they're not saying, here's 72 cards, good luck.
No, they're saying, here is a plug-and-play infrastructure where the wiring is already perfected for you.
I want to drill down into the nuts and bolts here, because that super chip claim feels like it needs some evidence. The source breaks it down into 6 key components.
Right, and the GPU is only one part of the story.
It's the heart, but you're saying a heart doesn't work without veins in a brain.
Precisely.
So component 1, the Rubin GPU itself.
Right. So inside this cabinet, you have 72 of these things. A single chip has a computing power of about 50 PFLOPS. But when you combine them,
in the whole NVL72 cabinet,
the total power hits roughly 3.6 EFLOP PS.
those are just big numbers to most people. Can you give us a sense of scale? What does 3.6 EFLOP PS actually mean?
Okay, think back to the supercomputers of the early 2020s. To get that kind of power, you would have needed a machine that took up the floor space of a basketball court.
A whole basketball court?
Maybe even a football field, depending on the year. Now, it fits in a metal box the size of a large refrigerator.
That's a staggering density increase.
Yeah.
But, raw power isn't everything. You can have a fast engine, but if you can't get fuel to it, it just stalls.
And this brings us to component 2.
The Vera CPU, which I found fascinating.
This is where Nvidia is really showing their hand.
But why build their own CPU? I mean, Intel and AMD have dominated that market for decades. Why not just use a top-of-the-line Xeon or EPYC chip?
Because those chips are designed for the wrong job.
What do you mean?
A traditional x86 CPU, the kind in your laptop, is designed for complex logic, for branching instructions, running an operating system. It's a general-purpose brain. But in an AI factory, the CPU has one job: feed data to the GPU, nonstop.
The source used an analogy here that I really like. It said, using a standard CPU for this is like asking Einstein to carry bricks.
It's a perfect analogy. The GPU is Einstein. It's the genius doing the really complex math. But Einstein needs data, the bricks, to work on. If Einstein has to get up, walk over to the pile, and carry the bricks himself, he's wasting his genius.
And the x86 chips are... what, just bad at carrying bricks?
They're overqualified and inefficient at it. They want to read the bricks, analyze them, organize them. The Vera CPU is a custom chip designed for one purpose: be the best brick carrier in the world.
So it's just optimized for pure data throughput.
Purely for memory bandwidth and I/O, it just piles bricks on Einstein's desk so fast that Einstein never has to look up.
Got it. So it's a specialist. Now, you said earlier that this whole rack acts like one chip. How do 72 separate cards know what the others are doing without any lag?
That is the third component, the NVLink 6 switch.
Is this just a fancy Ethernet cable?
No, and that's a really crucial distinction. Ethernet is for networking computers together. NVLink is for connecting chips internally.
Okay.
It creates what they call a full interconnect topology with a bandwidth of 3.6 terabytes per second.
Okay, let's stick with the developer perspective. Why do they care about the topology?
Well, think of the old way, like a group of islands connected by slow ferry boats.
Yeah.
If you wanted to run a massive AI model, you had to chop it up. Okay, part A goes to island 1, part B goes to island 2.
And you have to code all of that data transfer yourself.
Which is a nightmare. You're basically managing ferry schedules. With NVLink 6, it's like they just drain the ocean. All the islands merge into one massive continent.
So to the developer, the 72 GPUs just look like one giant pool of unified memory.
Exactly. You don't have to worry about where the data lives. The switch handles it all instantly.
That seems like it removes a huge layer of complexity for the software engineers. But what happens if I need more than one cabinet? I mean, the big AI models, they need thousands of GPUs.
That's where components 4 and 5 come in, Connect X9 and Spectrum X. These are the networking layers for scaling out.
And the challenge there is usually diminishing returns, right? Traffic jams.
Exactly. If you connect 1,000 cabinets, these components ensure the performance stays linear. You get exactly 1,000 times the power. No traffic jams. That linearity is the holy grail for hyperscalers like Microsoft or Google.
Amazing. Now, I want to jump to the sixth component because this one actually made me stop and reread the notes. The cooling system.
Ah, yes. The warm water cooling.
The source says it uses water that is 45 degrees Celsius. That's 113 Fahrenheit. That is hot bath water.
I know, right?
We think of data centers as these meat lockers with massive AC units blasting. How in the world do you cool a supercomputer with hot water?
It sounds totally counterintuitive, but the goal of cooling isn't to make the chip cold, it's just to move the heat away so it doesn't melt.
Yeah.
As long as the water is cooler than the chip itself, which runs at maybe 80 or 90 Celsius, it will absorb the heat.
Okay, so just pure physics. But why 45 degrees? Why not use cold water just to be safe?
Because making water cold is incredibly expensive. You need chillers, compressors, massive refrigeration units. That runs a ton of electricity. By designing the chips to accept 45-degree water, you can just use a simple heat exchanger. You can rely on ambient air to cool the water loop, even in a hot climate.
So it basically eliminates the refrigeration bill.
Significantly. But here's the so what that people miss. It turns the data center into a heat source. Since the water comes out even hotter, say 60 or 70 degrees, you can pipe that directly into a district heating system for a city.
You stop wasting energy and start recycling it.
Exactly.
Okay, so we've solved the physical heat problem, but there seems to be a different kind of heat building up inside the logic itself.
Yeah.
The source talks about a shift from training to inference.
Yes. This is the pivot point for 2026. For a long time, the headlines were all about training building the brain. That needs brute force calculation.
Yeah.
But now we are in the inference era, actually using the brain to do work. And the bottleneck there isn't math, it's memory.
This is where the term KV cache kept popping up in the source. Could you clarify that for us? What is it?
Think of it as the AI's cheat sheet for the conversation. When you're chatting with an AI and you paste in a 50-page document and ask for a summary,
Right.
the AI has to remember every word of that document to generate the next word of the answer.
It doesn't just read it once and know it.
No. Every time it generates a new word, it has to reprocess the entire context to make sure it's coherent. To speed that up, it stores that context in a key value cache.
And the longer the conversation, the bigger the cache.
Exactly. And that cache lives on the GPU's HBM high bandwidth memory. That is the most expensive real estate in the entire computer.
So you're filling up your most valuable memory with just the cheat sheet, leaving no room to actually do the work.
It's like buying a Ferrari and filling the passenger seat with old newspaper so you can't take anyone for a ride.
Okay, I get it. So what's Nvidia's solution?
The Bluefield 4 DPU, the data processing unit.
And how does that fix the memory hog problem?
Well, think of the GPU as the CEO. Their time is worth thousands of dollars an hour. You don't want the CEO digging through filing cabinets to find an old meeting transcript.
No.
The Bluefield 4 is the highly efficient executive assistant. It holds all the files.
So the DPU manages the KV cache.
Yes, it manages it using cheaper, standard memory, or even storage, and it just streams the specific bits the CEO needs exactly when they need them. It decouples memory management from calculation.
It seems like it would just drastically lower the cost of running these things.
It changes the unit economics completely, and it proves NVIDIA isn't just throwing raw speed at the problem, they're architecting around the specific bottlenecks of how these language models actually work.
Speaking of architecture, let's zoom out. We've talked about the factory, the chips, but the source material has a whole section on physical AI. This is where things get a bit sci-fi.
Yeah, this is the vision stepping out of the screen. We're talking about robots, autonomous factories, self-driving cars. NVIDIA wants to provide the brain for anything that moves.
And to do that, they built Cosmos. The source compares it to a spirit time house, which I know is a Dragon Ball Z reference for a room where time moves faster.
Yeah, right.
But in practical terms, what is it?
It's a simulation platform, but simulation feels like too small a word for it. It's a physics-accurate training ground.
Why need that?
See, robots are terrible at learning in the real world.
Because if a robot drops a plate, the plate breaks.
Right. And if it trips, it might destroy a $50,000 servo. It's too slow and too expensive to let robots learn by trial and error in reality.
Come in Cosmos.
In Cosmos, a virtual robot can drop 1 million virtual plates in just a few minutes. It learns the physics of friction, gravity, and grip in the matrix.
So it downloads the kung fu and then wakes up in the real robot body.
Essentially, yeah. And we saw the result of this with Project GR0T, their humanoid robot foundation model. There was that demo at CES where a robot got pushed.
I saw that. It didn't look robotic at all.
That's the key. In the old days, a robot pushed off balance would run a script. Tilt detected. Extend leg 20 centimeters. It's rigid. The GR0T robot just stumbled and caught itself. It shifted its weight instinctively.
Instinct is a really loaded word for a machine. Are we saying it understands physics, or is it just a really good statistical guess?
That is the philosophical question, isn't it? But functionally, it understands the consequences of physics. It didn't calculate the angle. It predicted the fall and prevented it, just like you would.
And this same logic applies to their self-driving cars.
Yes, this is the shift to VLM vision language models for driving. Old autonomy was rule-based. If red light, then stop.
But the real world is messy. A rule book can't cover a person in a chicken suit jumping out of a truck.
Exactly. A VLM looks at the scene and understands context. It sees the chicken suit and thinks, that is an unpredictable object, I should give it space, even if it's never seen one before. It's reasoning, not just matching rules.
And Nvidia is open sourcing these models to car companies.
They're giving away the driver software so they can sell the car computer. It allows Toyota or Ford to keep their data privacy, which is huge for them, but they still have to run it on Nvidia hardware.
It's the platform play all over again. Okay, before we wrap up, I have to circle back to the beginning.
Yeah.
The angry gamers.
Right.
We talked about the lack of a 6090, but there was a software announcement, DLSS 4.5, that the source claims is actually more important than the card itself.
This connects right back to the theme of game over for brute force hardware. DLSS 4.5 is all about neural rendering.
And the stat that matters here is the ratio, 1 to 6.
Exactly. In a sequence of 7 frames of gameplay you see on your screen, the hardware only natively renders one of them.
Just one.
The AI generates the next 6.
Wait, so you're saying 85% of what I'm seeing on screen is hallucinated?
Predicted is the preferred term. But yes, the AI looks at that first real frame, predicts motion and lighting, and then it draws the rest.
That feels like cheating.
Does it? If it looks real and plays smooth, it's decoupling the visual fidelity from the hardware constraints.
So you don't need a monster card to get 4K at 120 frames per second anymore?
Not necessarily. A mid-range card combined with this very strong AI can match what used to require a top-tier powerhouse.
So the hardware becomes just the baseline canvas, and the AI is what paints the masterpiece.
Precisely, and it's why there was no 6090. They're showing us that the future of graphics isn't about more transistors, it's about smarter prediction.
Okay, so let's bring this all together. We've gone from these DIY clusters to massive plug-and-play AI factories, from simple chatbots to robots with physical instincts, from rendering pixels to, well, dreaming them up.
If we look at the big picture, Nvidia isn't just a chip company anymore. They are positioning themselves to be the utility company for the 21st century.
Like the electric company.
Think about it. The last industrial revolution was built on electricity and oil. This one is being built on intelligence.
And Nvidia's laying the plumbing.
They're laying all of it. If you want to simulate a robot, you use their physics engine. If you want to drive a car, you use their VLM. If you want to train a model, you use their factory.
So they aren't just selling the shovels during the gold rush, they're selling the water, the maps, and the land rights.
And that leads to the final, somewhat uncomfortable question for all of us. If intelligence becomes a standard utility, something you just subscribe to, like water or power, and Nvidia is the only one building the pumping stations.
What happens when one company effectively controls the tap?
Exactly.
That is a heavy thought. It's incredible technology, but the monopoly implications are staggering. We might finally get our game over, but we really need to ask who actually wins. That's all for today's deep dive. Thanks for listening.
See you next time.